Welcome to the Keeson Landscape Smart Irrigation Trainings. I am Spencer Coffey, and today we will be covering the basics of learning flow and setting alert thresholds using the WeatherTRAK system. If you would like this training in writing, I have linked both an English and a Spanish version of this training in the description. Today's training will cover all of the details about learning flow in the WeatherTRAK system. This training includes why learning flow is a vital part of saving water with WeatherTRAK, how we go about learning flow, and then how we use the learn flow data to set and explain each threshold in WeatherTRAK Central. As always, you're welcome to skip around to the information you need through the timestamps on screen now or the bookmarks embedded in the video. Let's jump right in. So, how does learning flow really work? All of the power of learn flow comes down to the two main players in your system, your controller and your flow sensor. Conceptually, all the controller is doing in this process is running manual irrigation and watching the water pass so it can learn and establish what a baseline for normal use should be. So, why is it important to learn flow in the first place? Learning flow is all about gaining visibility and control. When you know how much water each zone should be using, you can quickly spot when something's off, whether it's a break, clog, or low pressure. As a water manager, remember, you can't manage what you don't measure. Learning flow gives you the data you need to identify problem areas and respond efficiently. The result? Less water waste, fewer callbacks, and happier customers. It also gives you hard numbers to back up alerts or usage concerns if a client ever has questions. Here is your important disclaimer. Before you run the learn flow process, always do a wet check first. That means manually running each station and visually inspecting it. Make sure all the heads are popping up, spraying correctly, and that there aren't any breaks, clogs, or pressure issues. Why does this matter? Because the system is about to learn what normal looks like, and if you give it bad data, you'll get unreliable alerts later. Learn flow only works if the system is operating exactly how it should. Think of it like setting a baseline. You want that baseline to be clean, stable, and accurate. After you've wet checked your system, the learning flow process is very straightforward. First, let's head into WeatherTRAK Central. Now that we're here in WeatherTRAK Central, we're going to head up to the Controllers tab on the top of the page, which opens a drop-down with one option titled Learn Flow. This is where we'll be performing most of the initial work in today's training. It's important to note that you cannot learn flow from WeatherTRAK's mobile app and that you have to be in the website. After you've entered the Learn Flow tab, you can pick which controller you want to learn flow on by using this search bar right here. Before starting the learn flow process, it's essential to make sure your system is free of any alerts. As you can see, my controller has 2 alerts, but neither will affect the learn flow process, so we are okay to proceed. It is important to note, though, any station with an active flow or electrical alert will not run during learn flow, which can compromise the accuracy of the process. Simply clearing these alerts without resolving the underlying issues, like potential leaks, can cause the controller to learn incorrect flow rates, masking real problems. Now that we've ensured we don't have any alerts that will affect our learn flow process, we're finally ready to begin. While looking through this page, you can see that WeatherTRAK Central is already displaying some data about your controller, as well as its history with learning flow. This includes your station's list, if and when that controller learned flow last, what their last learned flow rate was and their assigned flow rate is, as well as their assigned gallons per minute threshold. Now let's direct our attention to the top left of this table, where we can select which specific stations we want to learn flow on. Or, if we want to learn flow on all of our stations, we can simply hit this box in the top left margin. The next step is to enter them into the queue. Now that I have stations in my Learn Flow queue, you can see that the Start Learning and Save and Schedule options are now available for selection. Now you can finally begin the learning flow process on your controller. I recommend scheduling your learn flow process close to the actual start time for your controller. This ensures that your controller is absorbing the most accurate data to your actual running conditions, making some of our steps down the line easier. Additionally, it is important that while you're learning flow, you aren't making any system changes to your controller. Occasionally, these changes will not register in the controller or the cloud, and you can lose some programming on your controller. Now that I've learned flow on my controller, we can begin establishing our controller's settings. First, to establish any new settings in the controller, we need to make our way to the program page in the dark blue bar at the top of your screen. This is where we'll be entering data and setting preferences for how the controller should respond to abnormal flow conditions. After you've learned flow, you may see that a station may not have a value assigned to it for one reason or another. This is where the user-defined gallons per minute option comes in. If you see any data in your table that appears to be missing or incorrect for whatever reason, you have the ability to manually set the station flow rate. For example, sometimes drip zones flow so low that they don't register having any flow rate. So what I would do is I would manually set it to about what I think the flow rate should be. Now that my controller has all new learned flow data, we can begin walking through how to set preferences on our controller's actions if it identifies abnormal flow while running. We'll start by editing the settings in the mainline brake alert section of the program page. This step is where we begin to use the learned flow data that our controller just acquired. We use the mainline brake threshold to determine when we want our controller to throw us this critical alert, notifying us that the system has exceeded the threshold for maximum use. We want to set this value 15 to 20% higher than the highest anticipated use case for the controller. The next step that I take is looking for the highest value flow rate in our gallons per minute column of our table, which on this controller is 74.3 gallons per minute. So, what I'm going to do is I'm going to take this number and multiply it by 1.2 to get 89.16 gallons per minute. This shows us our value that is 20% higher than our highest anticipated use case. So we're going to set our mainline brake alert threshold at 90 or 95 gallons per minute. I'll usually round up about 5 gallons per minute higher than the 20% higher category. So for this mainline brake alert, we're going to set it to 95 gallons per minute. This value is important to get just right, as you want it to identify when there is a real urgent problem in the field, but not to give you any false alarms. Remember, this value can always be changed in the program page if you get thrown false alerts. I also recommend, after making any changes in your WeatherTRAK programming page, scrolling up and hitting the Save and Send button so the controller receives these data points and can establish them immediately, and so we don't lose any of our progress. Then we want to change the mode setting on our controller, which always determines how the controller responds in the event that the measured flow passes the threshold that we just set. I have the mainline brake mode set to alarm and action, which means that the controller will alarm me by sending an alert and then take action, usually by closing the master valve. Next, we will establish the threshold for our no-flow alerts in a very similar way to how we set up the mainline brake alerts. This threshold is set to determine when we want our controller to throw us the critical no-flow alert, to tell us that there is no water flowing through our system when there should be. Just like setting your mainline brake alert, you should set this value to around 15 to 20% lower than your average lowest station. This is a little bit different compared to setting the mainline brake value because we can exclude some stations from the no flow alert down here in the Excluded Stations tab. This is an incredibly useful feature if you don't want to get sent any false alarms. A common example of a station that you would want to exclude from a no flow alert is a smaller drip station, where the gallons per minute is so low that your flow sensor may not be able to accurately track how much water is moving past it. As you can see, I've already excluded station 34 on this controller, because station 34 runs at just 4 gallons per minute, which is significantly lower than any other station on my controller. Here, as you can see, I'm setting my no flow alert threshold to 4 gallons per minute, because that's about 20% lower than my stations that run at 6.5 and 6.7 gallons per minute. Then, just like setting the mode on the mainline brake alert, we need to set the mode on our no flow alerts. I have mine set to alarm and action because a no flow alert can be an indicator of some much more serious problems in your irrigation system. Next, we need to set up our leak and extended leak alerts in our programming page. I have this threshold set at just 2 gallons per minute because I want my controller to alert me at any time if I have any water running when I shouldn't be. Next, we need to discuss how to set the conditions for high and low flow alerts to appear in our system, and set our preferences to what we want our system to do when the conditions we set for these alerts are met. As shown right here, we can adjust the offset percentage for high and low flow rates in the options of the Flow tab. These percentages can be adjusted in increments from 5% all the way up to 80%. I recommend keeping these values at around 25%, but if you get thrown false alarms, then you can always change them in the programming page. Again, always remember to save and send so all of the changes you make get sent to the controller. Congratulations, you've officially learned Flow and set all of the thresholds for your alerts in the programming page. Let's head back to the presentation and finish up this video. Here's the bottom line. Once you've got good baselines, fine-tune your alert settings so they reflect what's really happening on site. This is an extremely useful tool for both techs and water managers to understand what's happening on their properties without having to physically walk each station. These baselines, as repairs get made and mainline pressure changes, will inevitably change. I recommend you complete this process annually to ensure that your controller is using the most accurate data to what's really happening in the field. Flow data is one of the most powerful tools you have. Use it right and it'll save you time, water, and a whole lot of troubleshooting. Today, we covered the ins and outs of learning Flow, as well as setting thresholds for your alerts. Thank you so much for sticking around to the end of the video. If you have any questions, comments, or concerns, you can reach out to me or the great folks behind the Keeson information email provided on screen. If you need more videos like this one, make sure to check out my YouTube profile or the Heartland University of Excellence for more uploads. As always, happy watering!